Hello, welcome to this third video on partial fractions. We're looking today at using repeated factors. So we've got a linear over a quadratic. This will be 2 minus x, 1 plus x, 1 plus x. When we have the repeated factor like this, the 1 plus x, we have one fraction here in the next bit with just 1 plus x, another with 1 plus x squared. So that's the strategy. Let's start by writing out the initial equation. Okay, with that written out, we'll have a look at what we need to do. Well, the initial thing we need to do here, of course, is multiply through by the denominator of the left-hand side. So that's going to leave us with 11 plus 8x there straight away. We've got 2 minus x will cancel out. One of the 1 plus x's will cancel out. And the 1 plus x squared will cancel out here. So let's see what we get. Okay, as you can see, we've just got the 11 plus 8x. 1 minus x squared, lots of a, because the 2 minus x cancels out. We lose a 1 plus x, but we're left with b multiplied by 2 minus x, 1 plus x. And with c, the 1 plus x squared cancels out, so we're left with 2 minus x. So if you get your little algebraic multiplication correct here and you're cancelling through of factors, you've done a big part of the job. You must get that right, though. Well, let's try the next bit. Let's do some substituting like we did before. This is going to be a little bit more complicated. Now, if we do x equals minus 1, let's let x equal minus 1. What do we get? We'll get 11 minus 8x. So 11 minus 8. 11 plus 8, lots of negative 1. So we've got 3 equals. We lose the a. We lose the b, because they've got 1 plus x, 1 plus x. That's why I've used x is negative 1, but we do have something here. 2 minus minus 1 is 3. So 3c. So c is 1. Now, we're going to put in x equals 2, because the reason I'm putting x equals 2 in is to get rid of this. 2 minus 2 is 0. 2 minus 2 is 0. I can lose b and c. So we've got x is 2, 50. 11 plus 8 times 2. 11 plus 16 is 27. Equals, and then I've got a. 1 plus 2 is 3. 3 squared is 9. So I've got 27 equals 9a. A equals 3. Well, it's going to be pretty difficult to find b in the same way, because we lose b. If we get rid of a, or we get rid of c, we're going to lose b as well by using this idea of substituting in x equals negative 1, x equals 2 to make the bracket 0. So we try this. We do x equals 0. So we're going to create a little equation here. Well, x equals 0. We've got 11 equals 1a. 1 plus x is 1. 1 squared is a. So 11 equals a plus, well, I've got 2 minus 0, 1 plus 0, 1 times 2 is 2, 2b. Hopefully you can see where this is going. Plus 2 minus 0, so I've got 2c. So now that I've got a and I've got c, I can just use x equals 0. It's a nice, easy substitution to find the value. So 3 plus 2b plus 2 lots of c. C was 1, so that's 2. So 2b should be 6, and hopefully b is 3. So let's write out what we've got. So a is 3, 3 over 2 minus x plus 3 over 1 plus x plus 1 over 1 plus x all squared. Okay, if I were doing this in an exam, what I want to do is I want to see, well, does it work for at least a value or two? So I'm going to try x equals 0. This would be just a quick way to check. You might do this on your calculator. If x is 0, you've got 11 over 2. I believe, yep, 11 over 2, because you've got 2 times 1 squared. So you've got 3 over 2 plus 3 over 1 plus 1. Well, so let's just think about what that's 5.5. Not looking to be too fancy here. We've got 1.5 plus 3 plus 1. Yeah, that's 5.5. So it works for 0. You might want to just try another one. I think some people might think this is a bit of a crude method, but it gives you a bit of reassurance. So 11 plus 8. So you've got 19 at the top over 1 times 2. 2 squared is 4. So I think that's 19 over 4. Well, what's that? That's 4.75 if you want to delve into decimals. So if we put x equals 1, got 3 over 1, 3, plus 3 over 2, let's say 1.5, 1 plus 1 plus 0.25, and that does equal 4.75. Well, it works for at least x equals 1 and x equals 0, so we must be onto something there. Good chance it's right. Okay, that looks good. I hope it all made sense. Thank you.